So, warm wishes of the day. So, in today's class, I'm going to explain you two topics, right? And the name of these two topics are Mealy and Murray models. So, let's start it. So, as we have already discussed about it in our last class, okay? So, this why slide is just asking us that why we need to read this Murray or Mealy machines, right? So, actually, these are the two different ways, and through these two different ways you are able to express your finite state machines, or you can say that you are able to express your finite automata. Okay, so you can name it finite state machine or finite automata or anything. So we are now just representing our finite automata with the help of these two machines, that is Murray and Mealy machine. And why we are studying it? Because both of these have their own advantages and it is good to know them. Okay, so this is the reason we are doing it. And one more reason is that because it's an essential part of your curriculum, that is DOC, so we have to do it. Okay, so generally if we talk about Murray and Mealy machine, okay, so how you say that you have always logic. There is some logic that helps you to compute what will be your next state, right? And what will be the output for that. Okay, for any state, suppose you have this state q1 or q0, the initial state, and if you give it an input 0, suppose it will take you to another state, suppose q1. Okay, so for any logic, so here logic is that your q0 is getting 0 as input, right? And it will help you to compute next state. So what is going to be your next state? Your next state that you got is q1. Okay, so this is how you represent it. If you remember, you write it like this: lambda q0 on getting 0 will move to q1. This is how you represent it, right? So also it is taking you to the next state. This is new thing. Side by side, it is also generating an output. Okay, so next state that you got is actually a function of what is the current state and what is the input. You can prove it from this particular diagram that your q1 is dependent. When I am saying that it is a function of, it means your current state and input actually decides your next state. It means your next state actually depends upon your current state and input. So here, can you see that q1 you got, it depends upon your current state and what input you give to it. Okay, so next state is only, the next state is only dependent upon your current state and what input you get. Okay, but now here a new factor has arisen, that is output. So outputs are actually dependent upon two different things. Okay, so if your outputs that you get, right, they depend upon only the current state, it means you are working with Murray machine. But if your output depends upon current state and input also, it means you are working with Mealy machine. Okay, so you can just summarize it like this, that your Murray machine is that in which the output actually depends upon what? Only the current state. Okay, so your output is only dependent upon the current state. However, in Mealy machine, what happens? In Mealy machine, your output is a function, or it depends upon two things. One is what is the current state, and other one is it also depends upon the input. Got it? So this is the only difference between Murray and Mealy machines, that in Murray machine, the output depends upon only the current state, and the Mealy machine says that the output depends upon both current state and inputs. Okay, so this is actually the difference between these two. Okay, but inputs, your next state, this q1, is always dependent upon your current state and input. That applies for both. For Murray machine also, the next state depends upon the current state and input. For Mealy machine also, the next state depends upon current state and what input it gets. However, the only difference is in the outputs. Okay, the outputs of Murray machine depends upon the current state only. The outputs of the Mealy machine depends upon both current state and input. Okay, so on the basis of this, if we define Mealy machine, so what was the Mealy machine? You can see it from here. Mealy machine was that in which output depends upon current state also and input also. So while I am defining it, I am writing that a Mealy machine is defined as a machine. Obviously, it is a machine, and where you call it a machine, it is a machine in your subject, that is theory of computation. Okay, and how do you define it? Whose? It means Mealy machine's output values are determined by both its current state and current inputs. Isn't it the same thing that I have written here? That Mealy machine's output depends upon current state and input. Got it? So Mealy machine's output depends upon current state also, and also on the current inputs that state is getting. So output is dependent upon these two things in case of Mealy machine. Okay, so we will do all other things later. Let's now study Mealy machine definition. So in Mealy machine, it is also defined as a machine in theory of computation, that is TOC, right? Whose output values are determined only by its current state. It means output is only dependent upon the current state in case of Mealy machine. Only on the current state, your output of the machine. And this is the only difference. The definition makes it clear that what is the difference. Okay, so in case of Mealy machine, now I'm back again. In case of Mealy machine, maximum there are one transition at a time. Okay, so one transition at a time means if you have Q naught and you are giving it 0 as an input, there is only one transition. It means it will go to only one state. Okay, if you give it 1, maybe it comes back to Q naught. Only one possibility. Okay, so if Q naught is getting 0, only one outcome is Q1 that is generated. If Q naught is given 1, so only one outcome is that Q naught you get back. It means this Mealy machine is actually deterministic finite automata, where on the basis of current state and what input you are giving to it, it will tell you what will be the next state. The next state will always be 1 and it is predetermined. Okay, so it has 6 tuples. So if you define it on the basis of tuples, I have explained it earlier also. So it is represented by total these 6 symbols. Okay, so capital Q represent how many states your Mealy machine has. If I talk about this particular Mealy machine, so here Q is equals to, there are 2 states, Q0 and Q1. Okay, then Q0 is the initial state. Okay, so if I put an arrow like this, so here this is my initial state. Okay, and then this summation says that what are the input alphabets. So as you can see, the inputs are always of the type 0 and 1. It means your input alphabet is made up of only 0 and 1. Okay, O is the output alphabet. Here I have not represented your output. Okay, but if input is of the type 0, 1, the output is also of the type 0 and 1. I will show you with an example in the next slides. Okay, then this sigma, it is the transition function. Okay, and this transition function maps that on the basis of current, this is for input and what state you get. For current state, for the current input, what is going to be your next state. For example, if Q0, your Q is Q0, it means you are here and you give it 0 as input. What is going to be your next state? It will be Q1. It is determining that what will be your next state on the basis of your current state and what input you give to it. Okay, then lambda is actually the output function. How output is mapped. Okay, so for the current state, if you give it current input, what will be the output? So it depends upon 2 things. Can you see here? This output, this is output. It depends upon 2 things. The first thing it depends upon is the current state, and the second thing it depends upon is input. So isn't it the same thing I have explained, that your output depends upon two things, current state and input. Your output depends upon two things, current state and input. Okay. So on the other side, in case of Mealy machine, it again has these 6 tuples. Out of this is same like Mealy, the number of states. This is the initial state. This is the input alphabet it got. This is the output alphabet it got. Transition function is also same because your next state is a function of current state and input. The only difference between Mealy and Mealy is here, output function. Okay, in the Mealy machine, the output depends upon only the current state. Can you see here when I'm writing this thing? Output only depends upon Q is a state and O is output. It says that your output is only dependent upon current state. And in case of Mealy, what was it? Output depends upon both current state and the input. Okay, so this is here. The only difference is if I write it in a single slide, this is Mealy, this is Mealy. So for Mealy, your current state defines the output. For Mealy, your current state and the input defines the output. And on that it. So suppose I have provided with the transition table. So this is my transition table, right? Just wait. This is my transition table. This is a transition table, right? So in the transition table, I have the present state. Okay, the next state, which is represented by this sigma. Okay, and then there is this output, which is represented by this lambda. Okay, so in case of Mealy machine, right? You remember Mealy machine? What was Mealy machine? The output only depends upon current state. This is Mealy machine. So let's see here. So this is my output. Okay, so if to Q naught, this is the current state. All these are the current states. So currently my focus is on the very first state, which is the starting state Q naught. Okay, so to Q naught, if I give 0 as input or I give 1 as input, okay, the output states, the states only, the next states, they may vary. Can you see that to Q naught, if I give 0 as input, the output state is Q3. It means Q naught on getting 0, right? Q naught on getting 0 is going to Q3. Okay, and Q naught on getting 1 is going to Q1, right? What is this? This is the transition function for the next state that you get. Okay, and it is true because next state that you get is always dependent upon what current state is and what input you give it. Okay, and I am not interested in it. What I am interested in that my output depends upon what thing. Okay, can you see that even if the input is 0 or input is 1, my output is always 0. It means this 0 or 1 is not affecting my output. It only depends upon what current state is. Okay, so if it is Q naught, your output is 0. Okay, so for lambda, let me design the output function for lambda. For Q naught, the output is always 0. Okay, for Q1, even if you get 0 or you get 1, the output is always 1. It means for lambda Q1, output is always 1. It means it is only depending upon the states, this thing and not this thing. For Q2, for lambda Q2, what will be the output? The output is always 0, not dependent on 0 and 1. For the last one, For Q3 state, the output is only again 0. These two things, 0 and 1, are not affecting that output. And this thing actually has explained that in Mealy machine, output is only dependent upon the state, the current state. Okay, this current state, it only depends upon. For Q0, output is always 0. For Q1, output is always 1. For Q2, output is always 0. For Q3, output is always 0. Let me repeat it again, that I told you that Mealy machine is what? Where output is only dependent on the current state. Okay, so this is your current state Q, and this is the output. Okay, so if I look at this table, can you see that your output will not change? This is the output. If I talk about the very first row, this is the very first row. If I talk about it only. Okay, so what is the output? Output is 0. Okay, and what is the current state? Current state is Q0. Okay, so if Q0 is there, it is under consideration. I am considering it. If it gets input 0, this Q0, see like this. This Q0 is here. This is the starting state. Okay, if it gets input 0, it takes you to Q3. This is written here. Q0 on getting 0 will take you to Q3. Q0 on getting 1 will take you to, there is a new state, that is Q1. This is how it is written. Okay, but here I am talking about the next state generated on the basis of what input your current state is getting. Okay, even if it is getting 0, next state is changing. If it is getting 1, the next state is changing. Okay, next states are always changing on the basis of 0 and 1. But can you see here, output is single, output is always 0. Even the next state on 0 is Q3. The next state on, these are inputs. This 0 is input, this 1 is input. If input to Q0 is 0, the next state generated is Q3. If the input to Q0 is 1, the next state is Q1. So next states are changing for sure, but the output variable, the output is always 0. Let's do another example. Suppose I am considering this third row. In this third row, if the current state Q2 gets 0 as input, the next state is Q2. If the Q2 gets 1 as input, the next state is Q3. Although states are changing, output is always same, that is 0. It means this output is not changing on the basis of what state or what input you are giving. Output is always same. It means it is only dependent upon the current state. This is what I have explained to you earlier. So suppose I am giving input string 0 triple 1 to it. So this is the input string I am giving 0 triple 1 to it. Okay, and this is the input I am going to give this table, and I want to check what will be the output generated. Okay, so you start from Q0. You start from Q0, and the very first character you pass to Q0 is 0. Okay, so my focus is on the input first. Q0 will get 0, the first letter of your input. So if your Q0 gets 0, it means this is. If it gets 0, what will be the next state? Q3. It means from Q0 you will reach Q3. Can you see it is written here? Q0, if gets this 0, you will reach to Q3, right? For Q0 0, you reach to Q3. So this is represented here. And side by side, if it reaches Q3, what will be the output generated? Output is 0. Can you see? This 0 is written here, the output string. Next, you have reached at Q3. The next input you give to Q3 is 1. This one. Okay. So this is Q3 now. You give it 1 now. This is 1. Where it will take you? It will take you to Q0. Can you see? Q3 when gets 1 will take you to Q0. So this is how I've written. Q3 will take you to Q0. Okay. And what will be the output? Output will be 0 again. So this is 0 here again written. Okay. So 2 elements of your input string are processed. And where you have reached at Q0 here. The next element is 1. Okay. So now to Q0 you give 1. So it means this Q0 again gets 1. This one. Where it takes you to? It takes you to Q1. So it takes you to Q1. I have written it like this. And what will be the output? Output is again 0. Next time, the last, the 1. To whom I am going to give the 1? To Q1, right? Because I have reached at Q1. Now Q1 will get 1. So you will reach to Q2. Can you see? You will reach to Q2. And what will be the output? Output will be 1. Okay. And this is the error it has. Just don't consider it. So for the input string 0, 1, 1, 1, the output generated is 0, 0, 0, 1. Okay. And during the input, the transitions of the state is, it goes from Q0 to Q3, then to Q0, then to Q1, then to final state, that is Q. Final for it. Okay. So you always start from your starting state Q0. Okay. And what is the input? Input you got is 0, 1, 1, 1. Okay. So first I will process this 0. Okay. And this input, because this is an input, this input will go to the first input will go to the starting state Q0. It means Q0 got 0, this 0. Okay. So if Q0 got 0 means this 0 Q0 got as input, what will be the next state generated? It is Q3. It means from Q0 you are going to Q3. And side by side you have to check that for this particular line, what will be the output generated? Output generated is also 0. Okay. Now you have reached at Q3. So the next input 1 you will give to Q3. Okay. So let's look, where is Q3? This is Q3. Now it will get the next input, that is 1. So for 1, where it is going to take you to? It is taking you to Q0. Can you see here from Q3 you reach at Q0. And side by side what output is generated? Output is generated as 0. And now you have reached at Q0. So the next input, that is 1, you will give it to Q0. So Q0 next gets 1. So you will reach at Q1. Can you see I have reached at Q1? And output is again 0. So output is 0 here. Right? And the last 1 input I will give to Q1 because I am at Q1. So Q1 will get 1. So it means you will reach at the last state, that is Q2, and the output generated will be 1. And this is one error. Okay. So the output will be 0, 0, 1 for the input 0, 1, 1, 1. And this is the sequence of states to which it passes. So if I just show you what was Mealy machine? Mealy machine was that in which output is a function of both current state and input. It means your output will be determined by using these two things. You have to consider your current state also, and you have to consider your input also. So let's prove it from this particular transition table. Okay. So can you see here, if the current state is Q1, right, and input is 0 for the current state, if Q1 is the current state and you give it input 0, the state is always changing. It was changing for Murray also. Okay. For 0, state was something else. For 1, state was something else. in case of Moore also. But what is the actual difference between Moore and Mealy is that in case of Mealy, your output is also changing. For current state Q1 and current input 0, the output is 0. However, for current state Q1 and current input 1, the output is 0. It means don't consider it that ma'am both are 0. Okay, just consider that both have separate column of values for output. If I give you this example, this second line example, can you see here? This proves it better. If the current state is Q2 and the input you give to current state is 0, output is 1. But if to current state Q2 you give input 1, the output is 0. It means your output depends upon what is the current state and what input you give to it. If it is 0, a different set of output is generated. If it is 1, a different set of output is generated, which was not the case with the Mealy machine. With Mealy machine, only different set of states were generated, output was same. Here, different set of states are generated like Mealy, but also outputs are also different. This is clear now, bache? I hope it's clear now. And from here, I can prove that this output, this particular output, if I say this is output, it depends upon the input and the current state. It means your output depends upon current state and input. How you represent input? With this sign. Similarly, output depends upon the input that you give it. It means it is in it. This sigma, this summation has two values, 0 and 1, right? So your output depends upon what input it gets and what is the current state. Current state is Q1 or Q2 or what. Okay, now let's do this input thing. Okay, so now I am given with the string, input string. Let me write it somewhere here. Input is now 0, 0, 1, 1. I have to pass this input to this transition table and check what will be the output. Okay, so first I am considering this 0. So this 0 I will pass to the starting state. So if this Q1, this starting state gets 0, it means I am here. Where it will take me? The next state generated is Q3. Obviously, from Q1 you have reached to Q3. And what will be the output generated? Output is 0. So can you see here 0 is written? So I have reached from Q1 to Q3 when I give it input 0 and the output generated is also 0. Okay. Now this Q3 will get the next input, which is again 0. So Q3 will get the next input 0 and it will take you to Q2. The next state is Q2 and what will be the output generated this time? The output is 1. Okay. Now I have to deal with the next input which I have to give to Q2. So Q2 will now get this new input 1. So when it gets 1, this Q2 will take you to Q4. So here 4 is written, Q4. Okay. And also if it is taking you to Q4, the output generated is 0. So 0 is written here. The last I am now doing, the last one, the last input which I have to give to Q4 because I am at Q4. This Q4 will get 1 and it will take you to Q3. Can you see you have reached Q3 and what will be the output? It is 0. Okay. So in case of a Mealy machine, you get the output only on the application of an input symbol. This is the input symbol. This will be the output. This is an input symbol. This will be the output. Okay. So this is the final output string generated. If this is the input given to you, what is the final output string generated? It is 0, 1, 0 and 0. So in Mealy machine, what happens? The main difference, the very first difference is on the basis of output. In Mealy machine, output depends upon the current state or present state and the present input. However, in case of Mealy machine, output depends upon only the current state or the present state. Okay. And if you just check maybe later on, The Mealy machine, it has less number of states. Mealy machine has generally more number of states. Okay, so I have not given you any transition table, transition diagram here. From this Mealy and Mealy machine, there are 4 and 4 states. They have both same states. But generally, when you will get a real life transition table or diagram, so Mealy machine, it has less number of states, and the Mealy machine, it has greater number of states. Okay, so in case of Mealy machine, I am just mixing it Mealy and Mealy, and it is becoming something else like Mealy. I don't know from where it is coming. So Mealy machine, in case of Mealy machine, the output function, right? It is a function of the transitions. Transitions means the next states and the changes that you get. Okay, and when you get that transitions and changes, when the input logic on the present state is done. Okay, so input logic is also important in case of Mealy machine. Present state is important, but input logic, the input you are giving, is also important. Here, the output function is a function of the current state, only the current state, and changes at the clock edges. This is a back-end work that for every machine there is a clock that is controlling the work, right? But generally, if you talk, your Mealy machine is only dependent upon the current state. Okay, whatever state change it goes to, whatever will be the next state, your output is only dependent upon the current state. Okay, here it also depends upon the input logic. Okay, so the next topic that we are going to do is the minimization of DFA. So just forget about Mealy and Mealy machine. That's about your Mealy and Mealy machine. Now I am back again to deterministic finite automata. And just to help you with it, deterministic finite automata was what? It was an automata in which the next state is already determined. You remember, if Q0 is the current state and you give it input 0, the next state is always be suppose Q1. For 1, the next state is always Q0. So the next state is always 1 in case of DFA. But sometimes the DFA that we get, it is very complicated. It has, suppose the DFA, the transition diagrams that we get, sometimes what happen, it has 10 states or maybe 100 states. So in that case, what we need to do, we need to represent it in a minimal way. Which states we can discard so that I can keep it simple, not complex. I want to just discard the unimportant states. Okay, so how minimization happens? So minimization of DFA means reducing the number of states from the given finite automata. So minimization means if there are 10 states, if I am doing minimization, maybe I will get 4 states, the 4 important one states. Okay, so let's do this. This is the actually, these are the steps that we have to follow, but I prefer to do an example with you before doing the steps. Okay, so suppose this is a DFA I got. Okay, and this is what, this is a transition diagram I have. So how many states are there? There is this initial state Q0. Okay, and how many final states I got? Can you see there are 2 final states, Q3 and Q5. Okay, and it is deterministic finite automata. How I prove it? Q0 if gets 0, you will reach to Q1, only one state. Q0 if gets 1, you will reach to Q3. For any input, one output state is determined already. This is deterministic finite automata. So this is a DFA that I got. Okay, and then there are Q2 also, Q4 also. So the initial state is Q0. How you know it? Because this thing proves it. And how many final states you have? You have total 2 final states. Q3 is also a final state. Q5 is also a final state. Okay, and other than there are states are Q0, Q1, Q2, Q3, Q4, and Q5. There are total 6 states in this DFA. Now I am about to minimize it. So let's follow some steps to minimize it. So now we are working on the minimization of DFA. So this is an example that I got. Okay. So the first step, very first step that you have to follow when you are doing minimization. Okay. So you have to just remove all the, just don't focus on this thing. Okay. The first step is remove all the unreachable states. Okay. The states where you are not able to reach. Okay, so for the current example, it has given that there are two states where you can't reach. One is Q2, another one is Q4. Let's see why it is saying that we can't reach them. Okay, so if we start from Q0 and we want to reach at Q2, is there a way to reach at Q0? Sorry, from Q0, if you want to reach at Q1, let's go step by step. From Q0, the starting state, if I want to reach to Q1, is it possible? Yes, it is possible. If I follow this path, I can reach at Q1. This is possible. It means this is reachable from the starting state. From Q0, am I able to reach to Q2? Let's see. So from Q0, if you follow this path, you will reach to Q1, and then there is no path that is taking you to Q2. If we follow this path from Q0, you will reach to Q3, and then there is no path that is taking you to Q2. Okay, so I can say here that Q2 is unreachable from the starting state Q0. If I talk about from Q0 to Q3, am I able to reach? From Q0, I can directly reach to Q3. This is the path I can follow. It means this is also reachable. From Q0, am I able to reach to Q4? Let's see. So from Q0, if I follow this path, this one, and then this one, then I am not able to reach to Q4. After that, there is no arrow coming towards Q4. If I follow this path, this one, this path, from Q0, I will reach to Q1, then I will reach to Q3, then there is no path going to Q4. Okay, so it means Q4 is also unreachable. We are left with one more, that is Q5. Let's see, from Q0, we are able to reach to Q5. So from Q0, if I follow this path, then I follow this path, I am able to reach to Q5. It means this is reachable. So there are two states which are not reachable, that is Q2 and Q4. So in the given DFA, the very first step is just recognize those states which are not reachable. So I have recognized that Q2 and Q4 are not reachable from the starting state because they are unreachable states. So I will remove them. Okay, so I just want to remove them. After the first step, what is the second step? So the second step is draw the transition table for the rest of the states. So by rest of the states, I mean that after deleting Q2 and Q4, you have just removed them. I have not removed them. It is just in my mind that I will not consider these two states. And for the rest of the states, which states we are left with? We are left with Q0, Q1, Q2 we have removed. Next is Q3, Q4 we have removed, and Q5. Okay, so removing Q2 and Q4, we have these states left, and I am just generating the transition table for it, where Q0 is my starting state and Q3 and Q5 are the final states. Can you see? Q3 and Q5 are the final state. Q0 is the starting state, and I have not considered this Q0 and Q4. I have just removed it. Okay, so how I prove I have removed it? I am just creating the transition table for the rest of the states. By looking at this diagram, I believe that you people are able to generate this transition table. How? Q0 on getting input 0 reaches where? Q0 on getting input 0 reaches to Q1. So this is Q1 written here. Q0 on getting input 1 reaches where? It reaches to Q3. Let's see. Q0 on getting input 1 reaches to Q3. Okay. So similarly for Q1, 0 and 1, these states are generated. For Q3, 0 and 1, these states are generated. For Q5, 0 and 1, these states are generated. So if you have a transition diagram with you, the transition table creation is not difficult. Next, we have this step 3. Okay, now what is the step 3? divide the rows of your transition tables into two sets. How many sets? Two sets. So I have this transition table. I will divide it into two sets. How? The very first set will contain those rows which start from non-final states. Okay. So the first set will contain only those rows which has the states which are starting from non-final states. Okay. Can you see? These are the final states. These two rows start from the final states. Which rows start from the non-final states? These two rows start from the non-final states. Q0 is not a final state. Q1 is not a final state. Okay. So I will divide this table into two sets. One set is of those rows which start from non-final states. Other set is of those rows which start from the final states. Can you see I have divided it same? Q0 and Q1 and its respective outputs, the other states, and then Q3 and Q5, which are the final states. Can you see? This is one set I have created. This is the another set I have created here. I have just divided it. The first set is only of those rows which start from non-final states. The other set which start from the final states. So what is the step 4? Now set 1 has no similar rows. Now we have to look on that is there any row in the set 1 which is same? No. This Q0 is taking you to Q1 and Q3. This Q1 is taking you to Q0 and Q3. Means both these rows are different. Okay. So if in set 1 the rows are different, it will be the same. It will remain same. It means the set 1 will remain same. It has no change in it. Remain same. Now let's focus on the step set 2. Can you see that in set 2, if you focus on Q3, for 0 also it is taking you to Q5. For 1 also it is taking you to Q5. With Q5, with 0 also it is taking you to Q5. With 1 also it is taking you to Q5. It means Q3 is also taking you to the same 0 and 1, to the same final state Q5 for 0 and 1. Q5 is also taking you to the same Q5 for 0 and 1. Okay. So in set 2, row 1 and row 2 are similar. How they are similar? Because Q3 and Q5, this Q3 and Q5 transit to the same state. When they get 0 and 1, they transit to the same state. Which state they are transiting to? Q3 is also transiting to Q5 on getting 0, and also on getting 1 it is transiting to Q5. Q5 is also transiting to the same state. Okay. Here what was the change? Here Q not on getting 0 going to Q1, on getting 1 it is going to Q3. But here for 0 both are, for 0 and 1 they both are going to the same state. Okay. So skip Q5 and then replace Q5 by Q3 in the rest. Now this is very important. As both look same, these both look same because this thing is same. So what I will do, I will just skip one thing. So I will skip the second one. Just delete Q5. It says skip Q5. It means just remove it from the second set. Okay. And replace Q5 by Q3 in the rest. It means here I have just deleted this thing. This is not there. I am left with only one row. This row, this very first row. Okay. And in the very first row, just replace this Q5 with Q3. So I am just replacing it with Q3 and Q3 because both are considered as same. Q3 is also taking you to the same. Q5 is also taking you to the same. So Q3 and Q5 are considered same. So I have removed it. And in the one row that I have left, I am replacing Q5 with Q3 and Q3. It means this will become like this. Q3 on 0 also Q3. Q3 on 1 also goes to Q3. This step is a bit complicated. Now let's combine it again. So from set 1, we will get these two rows. And from set 2, we will get only this row. Now let's combine them again to form a single table. So we have this single table now. This is the These are the two rows which we get from set 1. And this is the one row which we get from set 2. And out of these rows, Q naught in the original transition diagram was the starting state. And we have only left with the one final state, that is Q3. Can you see? Q5 was also final state, but as we have just replaced it with Q3, it means it is not there. So we have left with only one final state, that is Q3. So that's why I have written it like this. Okay. So I'm just combining the set and generating this transition diagram. Sorry, transition table. Now, if you have transition table, are you able to draw the transition diagram from it? Yes, it is very simple. Now we are left with only 3 states: Q0, Q1, Q3. Can you see? Q0, Q1, Q3. Where Q0 is the starting state, Q1 and Q3 is the final state. Q1 is not the final state, it is a normal state. Q3 is the final state. Okay, and use this thing. Q0 on getting 0 reaches to Q1. Q0 on getting 0 reaches to Q1. Q0 on getting 1 reaches to Q3. Q0 on getting 1 reaches to Q3. So this is how you can generate the entire transition diagram. That's all for today. So I hope you have got the right understanding and you have enjoyed this class.